All right, I think we can get the party started. Hello, everyone. Welcome to our Cockroach Labs half-hour webinar. I'm your host today, Chris Casano. And if all goes well, maybe I'll be your host again sometime in the future. We have a fantastic audience today. Thank you, everyone, for joining. It's matched by an incredible guest that we have here today. It's going to be a great day. We're going to talk about how to architect distributed transactional applications. That's not a mouthful. That's just a really simple concept. What's great today is that we have a special guest who actually wrote the book on this topic, and he wrote the book in exactly the same name. It's how to architect distributed transactional applications. So, ladies and gentlemen, I give you one of the finest humans on the planet that's joining us today, Guy Harrison. Guy, you want to quickly introduce yourself?
Wow, thanks, Chris. Yes, hi guys, I'm Guy Harrison. I'm a database professional who's been around for more decades than I care to admit. I've written several books on databases, about 7 or 8. I think I've actually literally lost count, including the Cockroach DB Definitive Guide, lots of books on Oracle, MySQL, that sort of stuff. And most recently, I co-authored this short book on architecting distributed transactional applications. I'm really happy to be here.
Oh, it's really great to have you here, Guy. And I think you do need a bigger intro. I mean, you've done some amazing work over the decades. You have if anybody has ever gone to guyharrison.net, you should go. He has countless amounts of blogs that range anywhere from virtualization all the way to stored procedures. There's a lot of great content there. He's also the CTO of ProvenDB. It's a great, fantastic service that helps you prove the ownership and validity of documents. So I'm really glad that you're here to share with you all of the knowledge that you've accumulated over the years and kind of summarize it in a great story of how to architect distributed transactional applications. So
thanks, Chris. Hey, I just want to mention for everyone, just yesterday, ProvenDB got acquired by OneSpan. It's a digital agreements company, so we're all very happy about that. Stand by, stay tuned for more info. If you're following ProvenDB, we'll let you know where we'll be going next. But big infusion of resources and big step forward for us. So we're very happy.
Wow, exciting news, hot off the press. Congratulations, that's awesome to hear. So, Guy, one thing I noticed, as we got to know each other and so forth, we both actually have. Both have big families, and I noticed your wife is also called Jenny. My wife is also called Jenny as well. So one thing I thought it would be funny is, like, if we ever created our own database, it would be funny to actually create a database called JennyDB. That would be not necessarily MariaDB, but like a JennyDB. And,
yeah, well, you got to watch out if you do something like that, that you're really committed to the relationship for the long term. Then, so yeah.
Exactly, and what better way to talk about distributed transactions than talking about JennyDB? But that's neither here nor there. Like you said, you've been in the industry for a long time, and you've seen countless amounts of databases, of architectures, of different types of applications. What keeps you motivated in the database industry? What keeps you going here?
Yeah, so I am still a really enthusiastic practitioner. I love technology. I love software of all sorts, and I'm still fascinated by databases. A short personal story. When I was very young, my parents took me to see the movie 2001, which is a classic science fiction movie, and it has this computer called HAL in it, a talking computer that runs the spaceship. And I was fascinated by the idea of a computer that could do all these things, and I wanted to live in that future. In which computers were doing it. It's a bit like ChatGPT. We've just got to the point where we're sort of talking to the computers and they're talking back in a sensible way. So I've always had this great enthusiasm. It's just part of my nature. I wanted to live in the future, and I'm really happy to be living in it now. But the other thing I'd say is I've always embraced new changes and new technologies. And the biggest mistake I've seen with colleagues and people who work with me is to get stuck on one technology stack. You learn, I don't know, Node.js, and you decide this is the one for me, and I'm going to stick with that, and it'll keep me my whole career. It's just not going to be that way. Everything changes, things get replaced, and you should take each new thing as an exciting opportunity to learn more. And if you do that, I think you can stay completely enthusiastic and engaged, for a very long career.
I agree. Yeah, it keeps you relevant, keeps your mind fresh. allows you to ask new questions. And speaking of asking questions, for those of you that can ask the best questions today, we'll probably limit to about 5 best questions. We're actually going to send you a hard copy of the book that Guy authored here on architecting distributed transactional applications. So do use the Q&A. We'll have about 10 minutes at the end that you can ask your own questions to Guy. So that's great. Yeah, always keeping fresh, learning new technologies is a wonderful thing. So, with that in mind, let's think about the past, right? So, distributed systems are not something that's simple. It's a very complex system. What was it like maybe architecting, distributed systems, in the earlier days? What was that experience like as opposed to how it is now?
Sure. It was one of the hardest things you could set out to do, to build a software application that ran on multiple computers. We had lots of problems that have been solved today. We were generally setting these things up on physical machines, and so we'd have to set up those physical machines sort of by hand, each one, everything, every kernel parameter, every configuration, every piece of software that was installed. We'd be doing that manually. We'd do it over and over again, and it was very hard to get that right. And even when you got it right, you couldn't really repeat the process easily like you can today. We didn't have a sort of like a reliable wide area network. So today the internet is available to us so that we can distribute software across the globe if we want. But in those days, really, you could only really distribute within one data center reliably. Sometimes we'd set up connections between data centers, but they were sort of flaky and unreliable and usually asynchronous. Scaling, wasn't, you had a distributed system and theoretically you could scale it, but to add a new node, you'd have to buy the node, get it shipped into the data center, connected to the network, hardware engineers, and then all that process of software engineering would be necessary. And the fault tolerance was sort of, you're probably trying to get fault tolerance out of this distributed system, but the database tended to be a single point of failure. So you'd have standby databases, but when they kicked in, it might take, 15 minutes, half an hour of downtime before everything sort of came up to speed again. So it was very laborious, very time consuming, and it didn't work very well. Now, in the past 20 years, a lot of things have come along that have made life so much easier. And just really briefly, virtualization was the first thing. Once we could have virtual machines instead of physical machines, we could copy them, we could duplicate them, we could move them around. Then the internet really came of age, and cloud services like Amazon, Google Cloud Platform gave us a platform where we could easily push things all around the world. And then more recently, Docker and Kubernetes have allowed us to take that sort of virtualization idea and bring it right down to the microservice level, so that we don't have to even think about the idea of a machine now is almost gone. It's services, and those services can be as big as small as you want, and there can be as many of them as you want. And then finally, with Kubernetes, we have this kind of like configuration and platform that's dealing with all the connections between everything, the relationships, the scaling. And it's miraculous for someone like of my age to see how quickly you can get a world-spanning global 24/7 application up in a day, something that would have taken a month or more, when I started in the industry. So it's a very exciting and very powerful sort of opportunities we've got today.
Yeah, fascinating stuff. And then, just speaking of that, right, going from all the way from virtualization down to microservices and Kubernetes as well with it, how have you seen the database kind of evolve over this time? Like what has changed about databases going back decades ago from how they are today?
Yeah. Well, the funny thing, in some ways it's really funny, because 30 years ago, I would have been working every day with Oracle, probably Oracle version 6. And, you don't need to know what Oracle version 6 was like. But if you took that sort of like 30-year-old version of me and put him in front of a database today, I'd probably recognize, it'd still be this SQL language in a lot of cases, concepts of transactions and relational schema. Those things were all established, a long time ago, and they're all still perfectly relevant today. So that's kind of amazing for something in our technology world where things are changing so much. This is 30 years ago. We didn't have iPhones, we didn't have the internet. But the databases in one way haven't changed at all. But in another way, they've gone through incredible evolution. And the most significant evolution was around about 2008, 2009. We saw this explosion of NoSQL databases, Cassandra, Dynamo, Hadoop. All of these things came and sort of toppled the relational databases king. And the reason is we needed databases, we needed distributed databases, and the relational database then wasn't ready. And as a result of not being ready to be distributed, a lot of people decided it was time for it to go. But, then we discovered that the relational database actually had everything we needed. What we really just needed was a distributed relational database. And so now we see SQL databases are back, but rather than being monolithic, only being able to be installed on one server, they've now got the sort of global scale of systems like Spanner and CockroachDB, and they're able to serve the needs of these distributed applications that we've been talking about.
Yeah, fantastic. And then, since you wrote the book, right? The book is really around transactional applications, distributed transactional applications, and obviously there's transactional databases that can sit underneath them, but what are the challenges that these applications seek to solve? Like, why do we need distributed transactional applications?
Yeah. Well, I think firstly, we've always needed transactional applications. You do want to know that when you make a change to the database, that it's going to take. You don't want to sort of update a sort of like an inventory count and have that inventory count just wiped away by another transaction that's happening at the same time. You really want to know that the data in the database is correct. And that's just been a fact since, all of my professional life. But what we're trying to do with distributed, we're solving a couple of problems that didn't exist when I started, but which are just mandatory problems to be solved now. Firstly, no one wants to have any downtime. When I started, it was pretty typical to say, we can take the database down on the weekend. It used to be, we'd shut the database down overnight to back it up. That was the
right.
Best case sort of like normal process, overnight cold backup. But now no one wants to do that. So what we need is a system that's not going to go down. And the only way to be sure something's not going to go down is to have it distributed across a sort of a wide variety of regions and zones, and have multiple data centers involved, and know that if any of those data centers fail, that the application can keep moving. And the other thing that's happened is that a lot of applications now are global. It's very rare to find a company that just seeks to serve a local region. I mean, they're there, cake shops, and so forth. But serious companies that want to expand, at least want to serve a whole country. But even typically, they want to serve multiple geographic regions. Australia, Europe, the Americas. And to do that, you want all of the people who are participating in that application to get good service. You don't want to say, well, if you happen to be living in Minneapolis, where our data center is, you're going to get sub-second latency. But if you're living in Australia, it's going to really suck. That's not a way to sort of build a global business. So we're distributing for those two reasons, to get really high availability, so that we're always up, and so that we can service a sort of a broader customer base and increasingly a global one.
That's great. Yeah. And, maybe continue on that thread too. Is there any specific applications you've seen that really kind of fit this new world of, distributed transactional applications, being able to span multiple regions, always having availability and uptime? What have you seen out there? What are the new use cases that, folks can gravitate towards to use this kind of new way of thinking?
Yeah, so there are definitely, you can sort of like break down sort of application types and into the ones that absolutely must have a distributed transactional nature, and maybe you can find some that don't. The ones that clearly have to are sort of like banking, finance, hospitality. You don't want to turn up at a hotel and find that your room's gone because the system was sort of not able to reconcile two competing attempts to book the room. Ticketing, retail, you want your inventory to match what's actually on the floor. Government data, records, you don't want birth records just disappearing because there was some kind of eventual consistency failure. So, and all of those systems too, like almost all the ones I've mentioned, need to have need to have high availability. Maybe it's just high availability within a city, but typically high availability across, a larger region. So, most modern applications of more than trivial scale need that sort of distributed nature. What are the ones that don't? It's harder to sort of like identify applications that shouldn't have this. If you've really got something that's only inside a company, that there's no sort of external customer access to, and for which you don't need it to run overnight, and maybe no one really cares if it's not up at all. There are such applications, but a lot of times what we've seen is those little applications built on a sort of a server under someone's desk, or at least in the old days, that's what it would be. Now it's probably on a VM in EC2 or something. But those tend to grow up, and when they grow up, they end up, being imported into the data center, and then they do sort of like take on those higher requirements. So, I wouldn't. It's hard to sort of assume that an application doesn't need 24/7 uptime. But the way I think about it today is, why not build distributed from the start into almost any application? Because it's so easy to do now. I mean, I don't want to trivialize it. There are a lot of things that need to happen for a reliable distributed application, but it's still something that if you have the right skills, you can establish something on a cloud platform that's distributed, in half a day. Something really simple, but you can take an existing, say, a Node.js application, package it up, deploy it to the cloud, and have it running as a distributed application against a distributed database like Spanner or CockroachDB. I could do all that, before the weekend was gone. So why wouldn't I do that? Why would I build the thing that's not going to scale deliberately? And I can't really think of too many reasons. So in my mind, anyway, these distributed transactional patterns, they're just the new normal. They're what everybody should be learning. And it shouldn't be, do I need distributed transactional capabilities? It's why on earth wouldn't I build in this capability into my application?
That's right. Just read the book and get going. That's simple. So probably, we probably have another question too, and then we can start getting to the audience questions as well. There's actually one thing you raised when you were talking about, distributed transactional applications. You talked about reservation systems. And did you ever watch Seinfeld before? A Seinfeld fan at all?
During the first runs, I watched them all. I'm not instantly thinking of the episode you're thinking of.
So there's something that just I remembered. There was a scene where Jerry Seinfeld is going to a car dealership, and they don't have his reservation. And he said one thing that was really just stuck out to me. He says, you know how to take reservations, but you don't know how to hold a reservation. And that's exactly what, distributed systems can help with, right? Being able to hold those reservations, not just take them, right? Being able to have consistency with the data. So I don't know. It would make a good.
So there's something. Yeah, there's something interesting there that, again, this is sort of history, but when Amazon built their first version, they had to decide whether or not they were going to be consistent or always on. And they decided to be always on. And they decided that, you could buy a product and their database system was sort of inconsistent. And if two people bought the product at the same time, someone would miss out. But that was better than neither person buying the product. So they sort of deliberately did what you're saying. They took the reservation, but they didn't necessarily keep it. We don't have to do that anymore. That was done because at the time Amazon was setting up, they didn't have the technologies that we have today. Today, we don't need to make that compromise, in my opinion, anyway.
Great. That's awesome. All right, maybe one other question, then we'll get to the audience. But, for the aspiring developers or engineers out there that might be just getting started with building, distributed systems or working at, databases that span across regions, or applications that might have to span across regions to, make, latency really fast or what have you. What advice would you give them? What advice would you give to these, young developers or engineers that are just starting their career and looking to get into, distributed transactional applications?
Yeah. Well, I think we've mentioned some of the key technologies that I think people should be familiar with. You certainly should know your way around one or more of the cloud platforms, AWS, GCP, Azure. In fact, if you can make yourself familiar with all three, I think you're in a very good place in the market. And they're all kind of similar. So, the knowledge translates easily between one to the other. And then Docker, knowing how to package your services up in Docker containers, and something about Kubernetes, just enough to sort of, not all developers need to master Kubernetes, but I think it's important to understand how things work inside a Kubernetes environment, so that you can participate in the DevOps process of deploying to production. Those are all sort of key technologies. The language doesn't really matter. These things are all sort of language independent. In my world, we use mainly JavaScript and Go, but Java and other Python, it's all supported, whatever your language of choice is. I don't think that's super significant at the moment. Be careful about the database backend. I'm a fan of all databases. This is really true. I've never met a database I didn't like, no matter what the differences are, they've all got their pros and cons. But you should at least have in your toolkit, you should be familiar with at least one database that can do distributed transactional processing. By that, I mean a database that can be deployed across multiple nodes across the globe and still maintain transactional integrity across those. Now, there are obviously CockroachDB is hosting this call, and they're one of those databases. Their competitors would be Yugabyte, Spanner, probably. These databases are all capable of that. I've worked a lot with CockroachDB. It's an excellent choice, but I don't want to sort of like go into full sell mode because I don't work for them. But you should be familiar with that. I also use other databases like MongoDB and Cassandra where it makes sense. But in a distributed transactional application, that they're probably not the database that you'd be looking at. You'd be looking at something like Cockroach. Then one final thing about things to look at. I haven't mentioned this before, but Kubernetes is great, but it's like a platform that requires an administrator. If you've got a serious Kubernetes application, then you're going to have one or more Kubernetes experts, and there's reams and reams of YAML files that define the Kubernetes deployment. And it's non-trivial to maintain that. Kubernetes becomes the kind of failure domain that you need to manage, and you need expertise for that. There's a new wave of technologies called serverless, which are being offered by the cloud vendors and database vendors. And in these cases, you don't need to worry about the physical or the virtual architecture of your system. Yes, there are containers, but you don't have to worry about them. You just ask the cloud service to run them. Behind the scenes, they may use Kubernetes, they may not. But all of the Kubernetes complexity goes away. Now, some of that complexity, some of the simplicity that you gain, you lose some flexibility. But for some applications, serverless is a perfect fit. So this is things like Google Cloud Run, AWS Fargate. These let you sort of really quickly deploy into the cloud a scalable microservice that requires no admin whatsoever. And some database vendors like CockroachDB have serverless database offerings as well, where you don't have to worry about how many nodes you have. You don't have to scale them up or down manually. You just say, give me a database endpoint, scale it as the demand requires. And you can, if these work for you, they don't always, but a lot of times they will, you can forget about everything but coding. And you can just say, I've got my platform, I throw my code into my platform, and all of the management is dealt with by the cloud vendor, and I just have to worry about solving customer problems. And so I'd encourage everyone to sort of like be familiar with those, because when they work, it's beautiful.
Awesome. Thanks for that, Guy. All right, so I know we only have a few minutes, so we might get only to a handful of questions, but let's go to the audience. There's actually a lot of great questions here. I think we have almost 26 questions, so we're not going to hit all these in the next 5 minutes, but let's start with a couple. Let's start with what we have. So what changes should we make to a traditional database schema design to optimize taking advantage of distributed transactions?
Great question. You don't have to make many changes. This does somewhat depend on the database. I'll just use CockroachDB as an example because I'm very familiar with it. In CockroachDB, you don't need to change the schema, but you can apply survival goals and to the whole database. So regional survival, zone survival, and then you can apply settings to individual tables to say how the data will be distributed across regions and zones. So you can say a table's global, in which case it'll be copied to every region. Very good performance for reads in every region, but when you do a write, it has to update all the regions. So it's great for reads, not so good for writes. And then regional by row will take some rows and place them in Europe and other rows and place them in Australia or North America, depending on where the traffic comes from. And that sort of is a great optimization. So it's not so much the schema, it's the sort of like the definitions you place on the tables within that schema. And in the book, we talk about that at the very end, about how to sort of like very briefly on how to organize those tables, at least using sort of for those databases that support it.
Yeah. All right, great. We have a good question from Paul. He's interested about being able to upgrade databases on the fly. I would say, how do you upgrade distributed databases on the fly?
So it's generally speaking a rolling upgrade. So each node, so in a normal simple distributed database, you'll have 3 copies of data. You'll have at least 3 nodes. In the most simple, you'll have 3 nodes, and you only need 2 of them to maintain availability. So one node goes down, gets upgraded, comes back up, then you move on to the next and the next. And so you've always got 2 of the nodes up at any given time. It's pretty much as simple as that. It's still a bit hair raising, but you don't have to bring your application down. In the serverless, when you're running it with a sort of a cloud vendor, so if you're buying your database service from CockroachDB or Google or someone, they'll do that for you. You won't even really need to worry about it. You'll just say that you're going to upgrade, and all those sort of like rolling upgrades will happen for you.
Okay, great. So Tom has a couple questions here. I'm going to take one of his. I think this is a good one. So Tom wants to know if he can take an app and point it to a distributed transactional database like Cockroach or something else. Is it possible that it will just work on its own, or is there any modifications that he'll have to make to the application?
Well, it's going to depend on what the back-end database was. So obviously, I think this is obvious. If you wrote it against Redis or something, you can't just port that to Cockroach. But if it was, say, Postgres, then yes, most likely a Postgres application would be very compatible with CockroachDB, and you might not even have to change a line of code. Different SQL databases, different amount of difficulty. Stored procedures, they're always database dependent, and so if you've got stored procedures, then you're going to have to do something about them. But the data types, there's sort of minor differences in data types. So there's always something to be done. But if you're going SQL to SQL, you probably won't have a very hard time with it. In fact, that's one of the reasons why I think when you're taking a monolithic application on a SQL database, at least if you're going to another SQL database, you don't have to change that data model layer. And that saves you a lot of effort. And it also means that you can test the 2 systems side by side, because you can compare the data in each in a way that if you move to a non-relational system like Cassandra or something, it'd be very hard to know whether they were the same after sort of you'd run some tests on them. Is the state the same? You have to write another program to check that.
Okay. We have about a minute left. I'll ask maybe one more question and then we'll have to cut it short, unfortunately. But Jerry's asking, what are some strategies for avoiding table locks when doing larger transactions?
Well, most transactional relational databases don't take out full table locks. So generally speaking, that shouldn't happen. The 2 main strategies are sort of called optimistic and pessimistic locking. So in optimistic locking, you don't take out the lock initially. You read the data, you prepare to do your update, and then at the very last minute, you check to see if the row is still what it looked like before you started. And if it isn't, you abort the transaction and try again. And that reduces locking a lot, because most of the time, no one else is looking at the exact same row that you're looking at. The other strategy, pessimistic, you lock. You use the for update clause of SQL to lock the row as you read it, do your modifications on it, and then commit. And that's sort of simplistic. It's more simplistic from a programming point of view. but it does tend to mean that you're holding these locks for longer. And so that's the major two patterns that have been around for an awfully long time for reducing row level lock contention. There's a few other things, always lock things in the same order. Don't have two transactions that are locking in alternate orders, because that tends to lead to deadlocks and a few other unfortunate things. But mainly decide on your optimistic or pessimistic strategy.
Excellent. Well, we do have about 30 other questions. I'm going to try to answer some of these for the audience here offline, and we can send them out. But that brings us to the top of the hour for the webinar, or the top of the half hour for the webinar. Guy, I wanted to thank you again for attending today and answering questions and producing a great book that, a lot of aspiring engineers or wise engineers can, use to start building some of the newest and modern applications that can, serve the world. So thanks again for joining, everyone. I hope everyone had a great time today, and cheers.
Thanks, everyone. Great. Enjoyed it. Bye.
Thanks, Guy.